here we're asked to solve this particular system of equations, which we know how to do by now. We knew how to do this in probably grade 10. We know how to do it with an augmented matrix, but what we're going to do is actually use a inverse to solve this system of equations for us. So one of the things we want to recognize, and you should hopefully be able to move back and forth with, is that this can also be written as a matrix equation in the form 2, -3, 1, -4 times the xy vector, column vector, is equal to the 0, 1 column. And so one of the ways that we could solve this is if this here is our matrix A, what I could do is multiply both sides of the equation. Sorry, not both sides, yeah, both sides of the equation, but left multiply both sides of the equation, that's important, by the inverse of A, because what that's going to do is on the left, cancel this thing out for us, which is the goal that we kind of want to do here, and leave us with xy equals the inverse A times the 0, 1 matrix. So basically, if we find this inverse, we just need to multiply it by the 0, 1 to get our solution. So yeah, we'll go through. It should be a pretty quick inverse to put together here because it is just a 2 by 2. So if I'll do 2, -3, 1, and -4, put it in the old augmented matrix. I'll just flip the rows because I like that 1 in the top. And subtract 2 of the first row. So that should leave me with 2 here. Sorry, no, that would be 3 plus 8 is 5. 1 minus 0, 0 minus 2 of those. And I haven't done anything to the top row. I'm going to divide that thing by 5. And I have some fractions, but it's not the end of the world. Just makes it harder to do things in my head. And yeah, I'm going to add 4 of that row now. So 1, 0. I do know I get that. Hopefully this isn't too bad. So adding 4. So add -8 over 5 to 5 over 5. We should get -3 over 5 here. And so again, if that is our matrix A, that does tell us that our inverse matrix here is going to be, I'm going to just pull out that 1/5 for simplicity. And we'd get 4, -3, 1, and -2. And so my xy, if I put it back into the work that we have over here, 1/5, and then this matrix multiplication. Just create a little divider here. And 1/5 times, do this multiplication, I should get -3 and -2. So xy is -3/5 and -2/5. And we should be able to check that if we kind of go ahead and plug it in there. I see that if I plug -3/5 and -2/5 into here, the x and y will cancel each other out to get 0, those multiples of x and y. And then if I do -3/5 plus 8/5, yeah, we end up with 1. So it's pretty checkable. And this is going to be our solution for x and y.